So in 12.3, we're going to talk about this thing called the tangent line. And the tangent line is associated with what we call a derivative, which is the kind of the lead into what calculus is all about, or at least half of it. And for us, really what we're going to be concentrating on in this section is this derivative thing, which really, up until this point in time, we've used the word slope. Or perhaps you could think about a rate of change. As I look at the picture in the middle of the screen here, what I want you to think about is, what is the slope of this line?
Y equals 3. Undefined.
Don't think too hard.
Y equals 0.
The slope is
0.
0. How about the slope of this line?
Y negative x.
Just one word.
Negative.
Negative. Thank you. Slope is negative. I don't really know what the number is, but I know it's negative, which means the slope here is
Up.
not up,
Positive.
positive. Slope is positive. That's it. That's what I want you to understand. 0, positive or negative. We're not going to talk about undefined right now. Okay, so one of the problems is whenever you're trying to find a slope, if it's not a line, is that's a little bit complicated because you really need 2 points to determine the slope. y2 minus y1 over x2 minus x1. So if I wanted to find the slope at negative 1, 1, what they're saying is I want the slope on this graph right at this location. So if I were looking at that picture, at that location, and as you look up here at this picture, what you'll notice is that my graph, going from left to right, is going down, which means my slope should be negative. And what they talk about is they talk about a tangent line to approximate that slope at that one location. I'm only supposed to be hitting that graph in one spot. So the only thing I really know about this slope at this one location is that it's negative. And what we're going to do is we're going to use a technique called the definition of the derivative in order to find the exact slope at that location. The main thing that I want you to know how to do for today, technique-wise, is what we call this slope thing, or the definition of the derivative. It is right here. The limit as h goes to 0 of f of x plus h minus f of x, all of that over h. Now, there are a couple things that you need to understand. First of all, there are actually 2 instructions going on. So I want to remind you about something. First of all, I want you to remember that when you see f of x equals something like x squared minus 3x plus 4, that means that there is a function. And f of x means the same thing as y. So if I told you, find f of 3, you would go 3 squared minus 3 times 3 plus 4, which would give you a 4 as an answer in the end. Or in other words, whatever you see inside of the parentheses, you plug in for the variable in the function. Does that make sense? Let me try another one, just in case. What if I said f of triangle? Then you would have triangle squared minus 3 times triangle plus 4. It doesn't matter what they tell you to plug in, you plug it in. With me? Okay. In the next problem down below here, I see that I have a function called y equals x squared plus 1. I'm going to use that yellow highlighted definition to find the slope at any location, and then I'm going to actually find what they're asking me for. So this definition I write down every time. Recall that we just got done saying, and it's kind of important, that y is really the same thing as f of x. They mean kind of the same thing. My definition of the derivative, or slope, was that my slope, m, is equal to the limit as h is approaching 0 of f of x plus h minus f of x all over h. I'm going to take this piece by piece. So let's just say, for example, I'm talking about this stuff right here in the pink. What that means is go back to the function. The function was, as I look at it, x squared plus 1. And in the x squared plus 1 function, I'm supposed to shove in x plus h. Very good, Sam. X plus h. So here's what's happening. I have the limit as h is going to 0. And in the pink, here's what's going on. I have x plus h squared plus 1. I'm putting brackets around this to show you what's going on in the pink highlighted instruction. I'm going to pause. Look, there's another instruction. It says, no, what color should I use? Light blue. It says, what about this? That tells me, look at my function, and wherever I see my function, shove in an x. Or in other words, this is what I get when I follow those instructions. Really, it's the exact same thing, right? It's the f of x function, because it said write down f of x. But don't forget you have this minus sign in between, and it's all over h. So at this point, I'm going to pause here because you have now completed all the f stuff, meaning look back in the function and plug in. And after that, it's just going to be algebra. Okay, so in this next step, all we're going to be doing is algebra. And I'm going to try and stick with the color so you can kind of see where things are going. The black is the stuff that was not an instruction, but it was part of the original formula. So I have that my slope is still the limit as my h turns into 0. And I have in my pink stuff, I FOIL out that x plus h parentheses squared. I will receive x squared plus 2hx plus h squared plus 1. This stuff right here, squared out, is this. In the light blue, if I distribute the negative sign, I get minus x squared and a minus 1. And on the bottom, I still have my h. Noticing that all the non-h things cancel out, I'm going to cross those out. So now I know my x squared here cancels with my x squared here. My positive 1 and negative 1 cancel out. And at this point, I'm not going to use any color. I'm just going to stick with the black. And I'm going to tell you that the limit as h is turning into 0 of 2hx plus h squared all over h is my slope. Now what this h going to 0 means is what we've been learning about for the last couple days. They're limits, remember? Limits are y values. And what we know is that we're supposed to, if we can, use strategy number 1. What's strategy number 1?
Plug it in.
Plug it in. But that's a problem. Because if I plug it in right now, you can't divide by 0. There's a 0 on the bottom. But watch what happens when I notice that on the top, each term has an h. So I factor out an h. And left over will be a 2x plus an h. And on the bottom, there is an h. And what I notice is that the h's top and bottom reduce out. So really, what's going on is I have the limit as h turns into 0 of 2x plus h. Are there any complications at this point of plugging in my 0? No, because I'm not dividing by anything. So I take that 0 and I shove it in, strategy number 1, for the h. So the answer to this is that my slope anywhere on that curve will be 2x. This is the slope anywhere on the graph. Have I answered the question that they posed? So now looking at the specific question that they posed, what I see is they want the slope at 1, 2. Don't forget that's representing an ordered pair of x and y. And in my answer that I found that my slope, which we call m, was equal to 2x. Or in other words, 2 times the x value. What's the x value here?
1.
It's a 1. So my slope that I'm actually looking for, in this case, is 2 times the 1. That's this value right here. That goes in for the x. Or in other words, 2. Now if I were to draw the graph, x squared plus 1, and I put the dot 1 comma 2 on there, and I look at what's going on, what that's saying is the slope is 2 there. But I could have asked you, what's the slope at negative 3, 10?
2.
And you could say the slope is
2.
negative 6. Because 2 times negative 3 is negative 6. And all you use is the x value to figure that out. So this 2x thing is a very powerful tool. It's the slope of the x squared plus 1 graph anywhere on that graph. And in calculus, we call that the derivative. So number 3, again, I start out with the definition of the derivative.